Keeper 3.2, partial sums in geometric series. Alright, so a partial sum is basically a sum up to a certain term. So if you have a sequence or if you have a series that you're counting all the way up to infinity, a partial sum might be the sum of the first 5 terms or the sum of the first 10 terms or something like that. So if you're counting just part of the terms, we call that a partial sum. Now, some sequences and some series, we can count all the way up. We can add all the way up to infinity. If the limit of that series goes to a number, we say that it converges. And if it doesn't go to a number or if it goes to infinity, we say it diverges. All right, so if you remember from back in the day, we have geometric series, which are in the form of some number times something raised to the n, or some number times something raised to the n minus 1. In this class, we're adding them up, so we're not just talking about the sequence being geometric, we're talking about the series being geometric because we're adding up the terms of the sequence. All right, so we have a partial sum formula, and we use that partial sum formula when we're only counting to a certain, or we're only adding to a number of terms, like maybe the first 10 terms or the first 20 terms. We want to add those up, we'll use the partial sum formula. Versus we have the infinite sum formula that we use when we want to count all the way to infinity. So we want to figure out what the sum is as I go out to infinity. All right, so the first example, it says, given the geometric sequence 2 times negative 2/3 to the n, find the third partial sum. So again, remember, since we're doing only the third partial sum, so we're only using the first 3 terms, we are using the partial sum formula. All right, so that formula says take a sub 1 times 1 minus r to the n over 1 minus r. The first thing I need to do is figure out my a sub 1, which is 2, because if I put 0 in for n, I get 2 times negative 2/3 to the 0, which is 2, times 1 minus r. R is the negative 2/3 to however many we're counting to, which is 3, all over 1 minus negative 2/3. Now simplifying that, I get 2 times 1 plus 8 27ths. Over 1 plus 2/3, or 2 times 35 27ths over 5/3. Keep change, flip that, I get 7 over 27 times 3/5, or S of 3 equals 14 over 9. This next example asks for us to figure out the infinite sum, so the sum all the way to infinity of the sequence 2 times negative 2/3 to the n. Now again, if we're trying to find an infinite sum, we use the formula a sub 1 over 1 minus r. And we can only use this if if the absolute value of r is less than 1. So since the absolute value of r in this case is 2/3, which is less than 1, we are able to use this formula. So plugging in for our first term, notice this time we have n equals 1 as our first n value. So I plug that in to get 2 times negative 2/3 to the 1, which is negative 4/3, over 1 minus r, which is negative 2/3. Clean that up, I get negative 4/3 over 5/3. And then keep, change, flip, and simplify, you get negative 4/5 as my infinite sum. All right, so we have something called the geometric series test, and we use this test to determine whether the functions or the series are converging or diverging. So if your series, if the r value of your series is less than 1, we say it converges. If the r value is greater than 1 or equal to 1, we say it diverges. And now if the series converges, we can use our infinite sums formula to find the sum of the series. All right, so the example 3 says determine whether the series converges or diverges. If it converges, then find the sum. So the first thing I'm going to do is I'm going to rewrite this to look more geometric. And so when I rewrite it, I'm going to do negative 3 squared, which is 9, over 10, all to the n. All right, then I want to look at my r value, figure out if the absolute value of that r value is less than 1. In this case, our r value is 9/10, which is less than 1, which means that this series does converge by the geometric series test. So again, if your r value, if the absolute value of your r is less than 1, the series converges by the geometric series test. And you must say it converges by the whatever test, because by the end of this unit, we'll have about 10, 15 tests, and you have to. Okay, well, since our series converged, again, we can find the sum of our series. And so using that sum formula, we have a sub 1 over 1 minus r. Our a sub 1 in this case is going to be 1, because if I plug in 0, my first term, into the function, I'm going to get 1 out, over 1 minus r. Remember, our r was 9/10. So cleaning that up, I get 1 over 1 over 10. Keep change flipping it, I get 10. In other words, the sum of my series is 10. Specify which one is which. Alright, so the next example says determine whether the series converges or diverges. If it converges, find the sum. So the first thing I'm going to do is rewrite it. So I have n equals 0 to infinity, 3 times 2 to the n. Here my r value is 2, which is greater than 1, which tells me that the series diverges by the geometric series test.